All right, welcome to Limits Day 1. As we do this, we are going to explore the concept of a limit. Now, that's as you see all the way on the right-hand side. Those are our ultimate goals. But in order to do that, we have to first look at the limit as it approaches from the negative side and the positive side. So a couple of things that before we get going, I need you to be aware of. All right, when you see this part with the X and the arrow on the number, that means X approaches 0. You're also going to see after this a negative sign, a positive sign, and then no sign at all. When we talk about the negative, well, think about X is approaching a negative. So therefore, we're talking about the horizontal axis, the x-axis, we're talking about as X comes from the left side, so from the negative side. With the plus, that means we're talking about it coming from the positive side, which means that it's going in this direction horizontally, and from the negative side, it's going in this direction horizontally. And then the f of x, don't forget, is a reminder that that's y. F of x is y. So when we're doing this, we are looking at the y value of points. That's the key to this, all right? Now, in order to be able to do the limit as x approaches 0, so this is the ultimate limit. This is like our end goal. The big thing here is that we need to understand that the limit as x approaches 0 from the negative side must equal the limit as x approaches 0 from the positive side. If those two are not the same, then we are going to say that the limit does not exist. Don't do no solution, don't do empty set, say DNE for does not exist. All right, let's go ahead and take a look at actual examples now, okay? All right, so I'm going to get rid of all this, and I'm going to go through and highlight as we go through. All right, so the first one, as x approaches 0 from the negative side. So what that means is here's 0 on the x-axis, okay? So I am coming along this curve, and I am approaching 0. And when I am approaching 0, it looks like I'm approaching the point 0, 0. So the y value is 0. So therefore, I am going to say that the limit is 0. But when I'm approaching 0 from the positive side, and again, we're talking about x of 0. So that I'm going to start basically on this graph. And as I'm going towards an x value of 0, it looks like I'm approaching 0, 2. Notice that my x value is 0, which means my f of x value is approaching 2. So therefore, I am going to say that the limit is 2 in this case. Now, because these two do not equal each other, we are going to say that the limit of f of x as x approaches 0 does not exist. All right, let's do this again. So I'm approaching an x value of 2 from the negative side, or what I'm basically sometimes saying is the left side. So x is equal to 2 is here. So I am approaching 2 along this graph because this is the one that is going towards 2 from the left. And as I'm approaching it, it looks like I am approaching the point 2, negative 2, which means my f of x value is negative 2. As I'm approaching this x value of 2 from the positive side, it looks like I'm approaching the point 2, 0, which means my f of x value is approaching 0. And again, since these two do not equal each other, I am going to say does not exist. And that's for x approaching 2. All right, a third time here. Okay, x is approaching 4. So here's 4. So it looks like I've got the point 4, 4. So as I'm approaching the 4 from the negative side, from the left side of this point, it looks like I'm approaching a y value of 4. As I'm approaching 4 from the right side, it looks like I'm also approaching the exact same point. So I'm approaching a y value of 4. Notice that these two are equal to each other, so therefore the limit as x approaches 4 is 4. The fact that there's a hole there doesn't matter, so don't worry about that. It looks like it's approaching that value, and that's all that matters. All right, go to page 2. All right, let's do this again. And there's a new concept that you're going to see on this page, and that's when we get to the h of, all right, and the h of. All right, we'll talk about that when we get there. All right, so x is approaching a -1 from the negative side, or the left side. So here is -1. So the left side of -1 would be this graph here. So if I am traveling along this graph, okay, and I'm getting closer and closer to an x value of -1, it looks like I'm approaching this point at -1, 1. So I'm more concerned about the y value, so therefore I'm going to say 1. As I'm approaching this from the right side, or the positive side, it looks like I'm approaching the point -1, -2. So the limit as x approaches -1 from the positive side is -2. Since these two numbers don't equal each other, the limit as x approaches -1 does not exist. All right, now remember, if it says evaluate h of -1, then we want to know the exact y value of, x equal to -1. And that is going to be the solid point. So therefore, we're going to go with a value of 1 because of the point -1, 1. We do not use the one with the hole. All right, let's do this again. Okay. As x approaches 3 from the negative side. Okay, so from the left side. So here's my 3. As I'm going towards a value of 3 from the negative side, okay, looks like I'm approaching 3, 2. So therefore, I'm going to say that the limit is 2. As I'm approaching 3 from the positive side, okay, from the right-hand side of an x value of 3. It looks like I'm approaching the point 3, 3. Okay, so therefore I am going to say it's approaching a h of x value of 3. Okay, these two are not matching, so therefore it does not exist. And then when I want to evaluate an x value of 3, then I'm looking for the one that has the solid point that's occurring with a y value of 2. Okay. All right. As we go to page 3, okay, just you're following the same idea. Your goal is to find the limit from the negative side, find the limit from the positive side, figure out if those two values are the same. If they are the same, then that is the limit for C. If they are not the same, then you're going to say does not exist. Okay, then you've got a couple of true-false situations occurring here that you need to evaluate. Okay, we did this one in class, so I am going to do this true-false one with you. All right, and just make sure that it's nice and clear. Okay, it looks like we have a hole there occurring, a line, a hole. We have a solid point, another hole that's connected. Okay, a solid point connected to a solid point, and then it's going off. Okay, so just so that it's nice and clear here. All right, so we're going to practice what we've been doing here. So we start with the idea that x is approaching -1 from the positive side, and it wants to know if it is equal to 1. Well, to me it looks like as I approach -1 from the positive side, so from the right-hand side of it, it looks like it is approaching that point -1, 1, so therefore I am going to say that this is true. Okay? It says the limit as x approaches 2 does not exist. Well, in order for that to occur, then that means from the left and the right, they have to have different values. Okay? But as I look at it, as I'm approaching 2 from the left, I'm approaching the point 1. And as I'm approaching 2 from the right, I'm also approaching the point 1. And since I'm approaching a y value of 1 for both the negative and the positive, then the limit does exist and it's equal to 1. So therefore, I am going to say that this is false. All right, it wants the limit as x approaches 2 is equal to 2. Well, we just figured out that it equals 1, so therefore we know that that is false. All right, x is approaching 1 from the left side is equal to 2. Okay, so here's my value of 1. And as I'm approaching from the negative side, so I'm approaching from the negative side, it looks like it is hitting the point 1, comma 2. So therefore, I'm going to say that that is true. All right, I'm approaching 1 from the positive side, and it's equaling 1. So if I approach 1 from the positive side, let me zoom in a little bit more here. Okay, and maybe even just use a different color since there's a lot of reds and blues in there. So I'm approaching 1 from the positive side. I'm following the graph along this way. To me, it looks like I'm approaching the point 1, comma 2. So therefore, f of x value should be 2. Okay, and they have it equal to 1. So I'm going to say that this is false. All right, now we just figured out that as x approaches 1 from both sides, it's equaling 2, so therefore it does not exist. That would be false, okay? Because it does exist. It exists at the value of 2. All right, the limit of, as x approaches 0 from the positive and the negative are equal to each other. Well, that means that at 0, which is right here, that from the positive side and from the negative side, they're going to the same y value. Well, it looks like from the negative side, it's going to 1, and from the positive side, it's going to 2. So therefore, I would say that this is false, that they are not equal to each other. And since they're not equal to each other, then that means that the limit as x approaches 0 does not exist, so it's not equal to 2, so this is false. On 22, all right, so it says C, okay? And what they're saying here, this is not a point. They're saying x values from -1 to 1. So that entire range from -1 to 1. So what I'm going to do is I am going to kind of section that off. All right. So from -1 to 1, what they're saying is that the limit exists for every single value. Well, we already figured out that the limit doesn't exist for 0 because it was approaching 1 and it was approaching 2 from 2 different sides. So therefore, that statement has to be false. All right, the limit approaches f of x exists for every value between 1 and 3. Well, here is 1, okay, and here is 3. And to me, since it looks like it is continuous all the way through, okay, there are no jumps in the graph, therefore I would agree that it is existing for this one, so this one is true, okay? All right, the bottom part here, okay, number 1, you can skip number 27, but on these, you have to create your own piecewise functions. They should look like the very first 4 graphs from the homework, and then you have to determine your limit. Okay, so just pay attention to the directions, you know, in terms of graph, determine the limit as x approaches, you know, the a value from the left and then from the right, and then figure out the limit. And the a value is the value that they give you in each particular question. All right, if you have questions, come see me.